This video is about bond length and bond energy. By the end of this video, you should understand how bond length depends on potential energy, understand the term bond energy, understand the relationship between bond energy and bond strength. When talking about bond length, we're generally going to be discussing covalent bonds. So let's start by considering why two nonmetals would come together in the first place. It turns out that a bond will form when a system can achieve a lower energy state by bonding. Recall that processes that lower the energy of a system are more thermodynamically or energetically favorable. So let's consider what goes into making this bond. First, we have some unfavorable interactions. These are the proton-proton interaction between the nuclei of each atom. We also have the electron-electron interactions between the electron clouds of the two atoms. However, there's also a favorable potential energy term in the proton-electron attraction. The system will attempt to minimize the sum of the unfavorable repulsions and the favorable attractions. Bond length, then, is the distance between the atoms where the energy of the system is minimal, where we've minimized the unfavorable repulsions and maximized the favorable attractions. Consider this diagram here, showing the potential energy change as two hydrogen atoms approach each other. Let's start here with them completely separate. Notice as they begin to get closer together, we have some repulsive forces, but we also have some attractive forces. The potential energy begins to lower. Eventually, they reach a distance where we've minimized repulsions and maximized attractions. This distance corresponds to the lowest energy state possible for this system. This is the desired distance between the two nuclei. Therefore, this will be our bond length. If we were to continue to move the atoms towards each other, we'd start to see an increase in potential energy as the repulsive forces begin to override the attractive forces. Notice also that when we get to this optimal length, the potential energy difference that we see here is our bond energy. In other words, it's the amount of energy released when the bond is formed or the amount of energy required to break the bond. Some things to consider about this potential energy graph. First, potential energy refers to the net potential energy, resulting from the sum of the attractions and the repulsions among the charged particles, the protons and the electrons. Also notice that at zero energy, we essentially have infinite atomic distance, meaning the atoms could be infinitely apart. That will give us a zero value for potential energy. Also notice the huge jump in energy as the atoms get closer than the ideal distance. Here we see a much larger repulsive force than attractive force. And again, bond length then is the distance between the atoms when the system has its lowest energy. Now let's consider covalent bond energies. Bond energy is the energy required to break a bond. It's also the energy released when that bond forms, since these processes are opposite from one another. The values for bond energy will not just depend on what two atoms are bound together. Instead, it will depend on the chemical environment of the bond. In other words, a CO bond in one molecule may have a different bond energy than a CO bond in another molecule, depending on what other bonds exist in that molecule. Therefore, we usually use a table of average bond energies. Higher bond energies indicate stronger bonds because these are bonds that require more energy to be broken and release more energy when they're formed. As the number of bonds or the bond order increases, meaning as we go from single to double to triple bonds, the bond length will decrease, meaning the atoms get closer together, and the strength of the bond will increase. Here's a table of average bond energies. Notice, as we said, a CC single bond has a lower bond energy than a CC double bond, which has a lower bond energy than a CC triple bond. That brings us to the end of this video. Let's review our goals. First, we looked at how bond length depends on potential energy. Then we looked at the term bond energy. Then we looked at the relationship between bond energy and bond strength.